Dear students, today it's our second module on data abstraction, and today we will discuss about lists, stacks and queues. So what is a list? A list is a collection whose entries are arranged sequentially. So for example, here we have displayed a list, and this list contains different names, and these names have a start which is denoted by head and the last entry as tail. So almost any collection of data can be envisioned as a list. For example, music recorded on a CD can be envisioned as a list of sounds. Then you could have guest list, you could have shopping list, for example the products which you are going to shop or which you have already shopped, class enrollment list, your attendance sheet in the classroom, and for example inventory list, the number of products available in a stock. So we traverse this list in different ways, and by restricting the manner in which these entries of a list are accessed, we obtain two special type of lists known as stacks and queues. So let's discuss them in detail. So what is a stack? Stack is a list in which entries are inserted and removed only at the head. So for example, here is a stack of books. If you have placed one book and you want to place another book, that would be placed on the top, the next book on the top, and the next book on the top. So if there is another book which we want to add, so we will add always on the top. So the method pushing is inserting a new entry at the top of the stack, and popping mean removing an entry from the top of the stack. So if we remove one book from the top, that would be called popping, and if we add another book on the top, this would be called pushing. So the head of a stack is called the top, and the tail of the stack is called bottom. And it has many applications, as we studied in one of the previous modules, like it can help us to trace the recursion. If we are doing any kind of backtracking, we are going to implement the stack. The next data structure or data abstraction based on list is queue, which is almost inverse of stacks, in which we have a list in which entries are removed only at the head and new entries are inserted at the tail. So this is called first in first out, and stack was called last in first out. So here we have a queue, and it has many applications. For example, if there is a queue of humans who are getting tickets for example any event, so the person who is at the start of the queue will be going outside of the queue, and the new person arriving in the queue will be placed at the tail. So in computer science, one of the underlying structure of buffer can be implemented as a queue, which helps us to move data from one location to another, and in between we implement a buffer so that if the sender has more speed or the receiver is not receiving the information or bits which we are sending more efficiently, then that information could be buffered, could be stored temporarily between those two locations. So here we can implement the queue. So let's summarize today's module. We have learned about lists, stacks and queues. We have learned that what are lists and how data is accessed within the list, forming stacks and queues.